Oh man, surface area is so easy. I agree. It's the easiest thing I've ever done in my life. I don't think it's easy at all. How do I find the surface area of a triangular prism? I think it's hard. I think there's a hard section. I think people get it conceptually, but it's difficult not to make a little mistake, especially when you're finding the surface area of a triangular prism. Dun, dun, dun. Okay, I didn't even use the net almost at all in the last problem, so I'll use the net a little more on this one. Use a net. A net is just when you unfold the three-dimensional, right, solid, you unfold this prism into a bunch of flat two-dimensional shapes. Use a net to find the area of each face. All right, we're going to do the same thing as last time. Finding surface area. What are the first letters of surface area? SA. So SA equals. All right. Well, let's take a look at this here. A lot of times students look at a rectangle and they go, that's a square. Well, let's look at this blue rectangle. How long is it? 13 centimeters. You can see it here. See the blue rectangle? 13 centimeters. How long is this bottom rectangle? 12 centimeters. Here's the red rectangle down below. I'm outlining it with my pen kind of right now. Maybe you guys got to see it, so I'll, whoa. There's the red rectangle. How long is it? 12 centimeters. Wait, so are the blue and the red rectangles the same? No, they are not the same. How about the orange rectangle? That's 8 by 5. That's not the same. All three of these rectangles are different. So what about the triangles? Are those different? No, that's what makes this a triangular prism. Prisms are when you have parallel faces that are congruent, or I should say identical. And the green front and the green triangle in the back would be congruent and identical. So if I found the area of this, let's say the front triangle, if I found the area of that triangle, what could I do to find the area of both the front triangle and the back triangle? I could multiply by 2. So I'm going to say 2 times the area of the triangle. Now we have to add to that, right? Because there's other two-dimensional polygons where I have to find the area of each of those. Okay, which one should we start with? How about we start with the one on the, I'm going to call this the orange one, the right side. Okay, I'm going to call that the right side. And then I'm going to call this blue one the left side. And the bottom's just the bottom. Okay. So we have the area of the triangles. Now how about we do the area of the right side? So here's the right side. Are there 2 of them or just 1? There's just 1. So we're just going to add the area of the right side, whatever that is. Then what will we do next? Maybe the bottom? Okay, the bottom, we're going to find the area of the bottom and add that. Plus the area of the bottom. Plus, now we have the area of the left side. That's all we have left is the left side. I'm going to call that L instead of S. So that's area of the left side. Okay, so far so good. So I'm going to make my little line which divides my left and right sides of the equation. This is going to be surface area every time on the left side. Okay, 2 times the area of a triangle. Oof, I said very early in the year. I said, just wait, you're going to forget this really important thing. When you find the area of a triangle, you have to, I hope I hear you out there, a triangle is half of a rectangle. You have to divide by 2. I hope you remembered. Did you remember? Well, if you didn't, you better remember because it's so easy to make that mistake. You're going to be like, oh, I got this. This triangle's 12 by, wait, which side's perpendicular? This slanty green side or this vertical green side? 90-degree angle box. This vertical green side. Okay, so this is 12. So this is 12 times, and then the height. Well, what's this height? Remember I said parallel edges are the same length. So this is 5 centimeters here. Don't forget to divide by 2. Okay, there's lots of ways to do this. If you're like, I'm an advanced student, technically you're multiplying fractions here. There's a little hidden 1 times 2. So this is 12 over 1 times 5 over 2. So the 12 and the 2 would cross cancel. This would become 1. This would become 2, or 6, sorry. That'd be 6 times 5, which is 30. If you don't know what we just did, which is totally cool if you don't know, whenever you have a fraction, you have to simplify the numerator and the denominator before you divide. That looks like a z, I know, it's a 2. 12 times 5 is 60. 60 divided by 2 is 30. That's 30 and centimeters squared, it looks like this time. So this is 2 times 30 centimeters squared. Plus, now we're going to do the area of the right. Well, the area of the right side is this side. And what are the dimensions? It looks like it's 8 by what's perpendicular? 5. So that area of the right side is a rectangle. How do you find the area of a rectangle? Just base times height. So that's just going to be 8 times 5, which is equal to 40 centimeters squared. Plus area of the bottom. Well, the bottom is also a rectangle, right? You can see it here. The bottom is also a rectangle, and it's 12 by 8. So that bottom is going to be 12 by 8. So I'll write A sub B is equal to, and I'm not going to rewrite the formula. It's the same formula, and I'm running out of space. 12 times 8. Oof, I don't know my 12s very well. Wait, 12 times 8 is the same as 8 times 10, which is 80, plus 8 times 2, which is 16. 80 plus 16 is 96 centimeters squared. Okay, now the area of the left, and I've almost run out of room. I'm going to barely go off, but that's okay. The left is this blue side, and this edge is 13. The slanty edge is 13. I'm really messing that up badly. The slanty edge is 13. The perpendicular, right, this edge, how long is that? It's 8. Remember, parallel edges are the same length in the case of a prism. So we have 8 times 13. I never learned my 13 multiplication facts. Oh, wait, can we use the same idea we did here? Oh, yeah. 8 times 10 is 80, plus 8 times 3 is 24. That's 80 plus 24, that's 104. If you're going, I don't know what sorcery you're using to do that, use a calculator. That's totally cool. I'm down with that. Looks like we have 2 triangles, so that's 60. So I'm going to rewrite this mathematical sentence here, this expression on the right side of the equation. Okay, now it's time to add. And you know what, everybody? I love tricks and everything, but I'm going calculator. It's just too much work. It's too much work, yo. And my calculator's very slowly coming up. Wait, I think it's coming up. Oh, it's not happy. It's mad at me. I hate when calculators get mad. Wait, there it is. Okay, here it is. So now we're gonna add, I don't know what this box is all about. There we go. Thanks for bearing with me because this is really fun, I'm sure. Well, 60 plus 40 is 100. 100 plus 96 is 196. Well, what's 196 plus 104? I could have done that in my head. It's okay. It's better that I check, right? It's better that I check. That's what Mr. Plunkett says. Make sure you check like 300 times. Because Mr. Plunkett's like, make sure you're accurate. Attend to precision. Mathematical practice standard number 1. Centimeters, wait, surface area. Area is square area. That's how many? 300 square centimeters it would take to cover this entire triangular prism. Okay, let's get rid of the calculator. And the area of a triangle is equal to BH divided by 2. Remember that the height of a triangle is blank to the base. Starts with a P. Perpendicular. Each edge of the triangle bases has a blank attached to it. Each edge, the bottom is attached to the bottom rectangle, This side of the triangle, this green triangle, is attached to this rectangle, and this side of the triangle is attached to this blue rectangle. So each edge of the triangular base has a rectangle attached to it. All right. A triangular prism has blank faces. How many faces? 1, 2, 3, 4, 5. It has 5 faces, 2 congruent, which means identical triangles, and 3 unique rectangles. Sometimes they're the same. Sometimes 2 of them are the same. But certainly they can all be different. You are all amazing. You're doing a great job. I wish I got to hang out with you, but I'm glad we get to hang out with each other on the old YouTubes. Have an excellent day.